In this video, we're going to build a robot from scratch using URDF and spawn it in the Gazebo simulator. No hardware needed. Everything runs in simulation. URDF stands for Unified Robot Description Format. It's an XML file that describes your robot, its body, wheels, joints, and how everything connects together. ROS uses this file to understand the structure of your robot. Let's start with the base footprint. This is an invisible link that sits on the ground plane. It's the root of our robot's transform tree. We attach the base link to it with a fixed joint, raised slightly above the ground. The base link is the body of the robot. We define it as a box, 30 centimeters long, 20 wide, and 10 tall. Inside each link we need three things: a visual for how it looks, a collision shape for physics, and inertial properties for mass and how it resists rotation. Now the wheels. We add a left wheel joint as a continuous type, meaning it can spin freely without limits. The origin places it at the left side of the body. We rotate it by 90 degrees so the cylinder stands upright as a wheel. The axis tag tells Gazebo which direction the wheel spins. The wheel link is a cylinder with a 4 cm radius. We give it a black material color. The right wheel is identical, just mirrored to the other side of the body. For stability, we add a caster wheel at the front. It's a small sphere with a fixed joint. We set its friction to 0 so it slides freely. This gives our robot a 3-point contact with the ground, 2 driven wheels at the back and 1 passive caster at the front. Now the Gazebo plugins. The differential drive plugin is what makes the robot actually move. We tell it which joints are the left and right wheels, the wheel separation distance, and the wheel radius. It listens on the cmd_vel topic for velocity commands. We also add a joint state publisher plugin so Gazebo reports the wheel positions back to ROS. This lets us visualize the wheel rotation in RViz later. Finally, we set Gazebo-specific material colors and friction values. Gazebo uses its own material system separate from the URDF visual materials, so we need to define colors in both places. Now the launch file. This is a Python script that starts everything we need. First, the robot state publisher which reads our URDF and broadcasts the transforms. Then Gazebo itself, loading an empty world. Then we spawn our robot from the URDF topic. And finally, the ROS Gazebo bridge to connect topics between the two systems. Let's run it. Gazebo opens with an empty world, and after a moment our robot appears. A blue box body with two black wheels and a grey caster. Now we drive it using teleop twist keyboard. Press I to go forward, J and L to turn, K to stop. The differential drive spins the wheels at different speeds to steer. In RViz we can see the robot model and its transform tree. The structure we defined in the URDF. And that's your first robot in Gazebo, built from scratch with URDF. From here you can add sensors like a camera or LiDAR. The URDF is your robot's blueprint. Subscribe for more ROS and robotics tutorials.